Right. Make sure I have all my windows. Okay, so yeah, welcome to class 5. I do want to get through some muddiest points of last time first and a little bit of housekeeping stuff. And so that's going to take a while. Just FYI, I have a couple things I want to go over that I want to clarify. So it will take a bit till we get to the real part 5 materials, but that's okay. I don't anticipate, I'm like 99.9% sure we're not even going to get through most of what I have in part 5, but we'll just finish it up next week. So not a problem. I will say that I did put the midterm, what I'm calling the final version, in that Dropbox folder, which I mentioned last time, that within that Dropbox folder that has all the parts, there's this midterm project. I did ask Colin to proofread it because I keep making typos in all your homeworks. So hopefully he'll let me know if he finds anything, or any of you can let me know. But it's pretty much what was in there last time. I just removed one function from there. And let me know if you have trouble finding a data set or want to run by anything. Any questions you have about that? Are there any questions right now? Did want to pull up the, oops, forgot to bring this up. So the data set that I suggest, like the like repo that has all the data sets for Tidy Tuesday was one I suggested that you could pull data from, but definitely if you have a data set that you work with already or from another source, that's totally fine. I just wanted to give you some options. But this is the Tidy Tuesday website. So if you're not familiar with pulling data from here, you can kind of read this little vignette about what the data format is, like how to find data sets. Pretty much every week is a new data set and they have a wide variety of topics. So it's not really easy to search through other than just kind of browsing it. And down at the bottom, they have a list. So you can look at, this is 2022. And so just if any topics look good to you, I saw some people posting about the chocolate bars. And so once you click on the name of the data, it will show you information about it. And it will show you exactly kind of how to read it in, basically. So you can see this is an example using read CSV and just using the direct website. You can do that if you want, or you can download this file and read directly from the file. But if you're having any trouble with anything related to finding a data or thinking of a research question, feel free to message me or email me or make an appointment, however you like to contact me. That sounds good. Okay, so going back to last week, talking about some of the survey results. Thanks again for everyone commenting and giving some feedback. I really like to read what you have to say. So last week was part 4, and there are a few, actually I noticed that some people had filled out the older survey, so I added a couple of those that I had missed previously. So one was about the read Excel function. I'll keep going over this and try to cover a little bit more about the arguments and such. Today, we're actually going to use read CSV because we haven't really used that, and I will show a little bit about that. So just trying to keep giving examples about reading in data. Eventually, I'll get back to Haven and we'll talk about reading in SAS and SPSS data or Stata data. But I do recommend, if you're still having trouble with Read Excel, to read their vignette. It's actually really good. And they give examples of like each argument. So if there's any argument that looks confusing, it's good to look at their examples because they explain it probably better than I can. And then another thing about saving plots with ggplot, ggsave is a little confusing because it doesn't require you to tell it exactly what plot you want to save. And that's because the default is just to save the last plot that was printed. That can get a little messy. I don't like to do that because I have a lot of code and sometimes I don't remember what the last plot was. And just to be clear, I like to save them as objects first. And I'm going to talk a little bit more about saving things as objects today after this. But what we do for ggplot, we save it as a name, as a ggplot object. And so let's say I want to make a scatter plot, and in here I didn't make, well, this is a different plot. This should be geom-box because I thought I was making a box plot. But anyway, let's say we have two different plots, two different names, and I want to save both of them, right? What I would do is save them as two separate ggplot objects. And note that when I do this, it's not printing anything, it's just saving it. So if I want to print it, then I call its name, and that's pretty much my first scatter plot. And then if I want to save those plots, I use ggsave, where I specify the plot object name. And so here I've saved the scatter plot, and then I've saved it as my scatter plot, and here I've saved the not quite a box plot and saved it as boxplot.png. And I'll show you a couple other examples today. And there are a lot of options in ggsave. You can set the size and the resolution and all kinds of things that are useful for saving plots. So we'll do more examples with that. There was a lot of comments that across was still muddy, and that's fine because we're going to talk about it again today. And I know that across is hard to use. So hopefully more examples, and then eventually we'll have some practice using across. And we're going to talk about across in the context of summarize. So we'll see a little bit more usages of that. I think it will take practice. Mutate is still a little blurry. That's all right. We'll keep using mutate. Mutate is, there's just so many ways to use mutate. Like I said, I could probably show 3 hours worth of mutate examples. It's just a very powerful function and can be used in a lot of different ways. So we'll keep doing more examples with that. And I think, yeah, I think it's one of the most useful tidyverse functions. I just use it for a lot of things. So there was this one challenge, I don't remember, maybe the first challenge last class. And so this question this was not 100% clear. And yeah, I kind of purposely made that a little tricky and new. So let me break down what's happening, not using the mutate statement, but thinking about how we go from a logical or Boolean vector to a numeric vector. So let's just make a smaller vector. It's like essentially a subset of what vital status was. Vital status is a character vector. It had 2 possible values, dead and alive. And so here's five of those. So if we look at that, my vec, I've called it, that's a character vector. That's what when we ask what is the class of that object, it's a character vector. It has length 5 if we were to ask what the length was. And so if we say my vec equals the double equals alive in quotes, we get another vector, and this is actually values of false, true, true. So that's false when it's dead, true when it's alive, false, true, true, right? So it's testing that statement along each vector. This is a example of a vectorized function, this kind of logical operator, because it's moving along the vector and testing whether each element is alive. This, I've just kind of run this. I haven't saved this as anything. So right now, in this line, I'm going to save it as a new vector called myvec underscore Boolean. And that's going to be this, this vector, which is a Boolean or logical vector. Here I've saved it, and then here I've printed it out. And so again, you get the same answer, false, true, true. And if I ask, what's the class of that vector? It says logical. Logical just means Boolean, means true, false. So that's one data type. We talked about data types in class 1, I guess. And we had numeric, integer, character, date is another one, and then logical is one of them. So that is a vector of type logical. And so then when we talked a little bit about why this works, and the fact is that when you try to do any kind of math on the logical or Boolean vector, it converts all the falses to zeros and all the trues to ones. And so this is a shortcut, actually telling it to multiply 1 times the numeric version of this, which is essentially saying, turn this vector into a numeric vector. And so we get 0 for a false here, false, true, true, right? So 0, 1, 0, 1, 1. And so this now, I haven't saved it as anything. So that's what I'm doing here. I'm saving it as my vec numeric now. And I look at the class of that vector and it's numeric. And so my vec numeric is 0, 1, 0, 1, 1. And so if we do that, all those steps all together in one line, instead of saving it as like my vec character, my vec Boolean, my vec numeric, and just do it all together in one line, you get the same answer. So here's the testing statement that becomes a Boolean vector. This is doing the math on that Boolean vector to make it a numeric vector. And so we've ended up with a numeric vector. So looking back at the original statement, that is what's happening in this mutate statement. I've just turned vital status, which was a character vector, into a Boolean because I'm testing it against this alive. Is it equal to alive or not? And then multiplied it by 1 in order to turn it into a numeric vector. And so I didn't need, this was not necessary. It was just sort of to show you what happens when you do that. If I wanted to convert it to a 1, 0, 1 variable, I would have just done this essentially, just that one line with within mutate. So hopefully that clears up a little bit more. Just going back and forth between Booleans and numeric values. And so another comment was Booleans, when are they more useful? I will say using them like I did just above is probably the most common way that I could think of that we use Boolean vectors. As a data type, I don't really use them much. Like I don't tend to store data as true and false. I don't make a column of true and falses, though you could possibly read in data like that. So just keep that in mind. But Booleans in general, those will pop up when we're doing other things, like if we're filtering. Often we filter on a true false value, right? So empty cars is a built-in data set. And so if we filter that data based on, it's about cars, so this is the cylinders, number of cylinders. So if we filter cylinder equal 4, that's a true or false statement. That's actually a vectorized true or false statement. So it's checking each row and it's looking at cylinder equals 4, yes. Cylinder equals 4, no. And so you get a long column of true versus false, and then it filters only where we have trues. And same with select, looking at the column names here, is numeric is a true false statement, is it numeric or not? And then things like mutate, this is a true false statement, is sil less than 6, is sil greater than or equal to 6. If true, then we do low. If true here, then we call it high. So these kind of things, like Booleans in action, I guess. We use them to help us do other tasks, usually, is how I think of it. Any questions about true, false, logical stuff? There was one that just said NA, and I wasn't sure if that actually meant NA or if they meant not applicable. So I'm just going to say that we will talk more about missing data. We'll have a little bit, you'll see one part in today's class where NA kind of come out to surprise us, and we have to deal with that. And but in the future, also, I'll talk a bit more about dealing with missing data. Not a whole lot today, though. And so in talking with a lot of you, I have a bonus muddy point that I've just observed, something that I haven't explained well, I realized. So I do want to go over this. Those of you who are super familiar with, let me hide my meeting controls. So those of you who are super familiar with this might be old news, but I just want to make sure this is clear to everyone, because it is a really odd thing to get used to. And that's about saving things. And I use this word saving kind of loosely. I know I say the same thing when I say save as an object, save as a variable, save as a plot file, save as a data file. But a lot of those things do mean slightly different things. So I just want to be clear what I mean and what is typical in our workflows. So these slides are on class 5, as well as linked to here. And so I'm just going to use the penguins data with the flippers and the bill length and so on. So that's loading the data. So just a few tips. When we filter, clean, mutate, when we're wrangling or cleaning the data and we're changing it somehow, we probably want to save that work. I think sometimes we do that just to like look at our data, but often we're doing the work because we want to clean up our data set. And so if you're changing the data and you want to use that data later, save your work, which means save as a new object or save as the same object if you want to overwrite that data frame within R. So in this case here, I'm filtering my penguins data set, and then I'm mutating and I'm making a new column. And so I could just run this part and I would get a table, a tibble, and as a result, I'd be able to see it in my output, but I wouldn't have saved it as an object in R. So that means I wouldn't be able to use it later. And essentially my work is gone after I've run it. I've run it and now that's it, it's over. So saving it as penguins_f tells me that I've made a new data frame or tibble, as it really is. I've called it penguins_f to let me know that's my female penguin data set. And so now that's in my environment in R. And later I can use that name at that object to do more things to it. I could save that data frame as a file. I could further mutate, or I could plot with it and so on. And so here's another example of doing that. Now I want to decide I want to arrange that. I want to sort my data by bill ratio, which was the new column I made. And then I resave it again to not lose that work. I want to keep my penguin F sorted. But both of these don't result in any output. So whenever you save something, it's doing that work and saving it, but nothing is being printed. There's no default print output. Nothing down here has come out. So in order to tell it, I want to print something, I can just print out the name penguins F and it will show me the whole table. In this case, I selected the columns sex and everything that contains bill. So we have bill length, bill depth, and bill ratio, just because I wanted, this is a kind of a wide data set. So if I had printed just plain penguins, it would have run off the page. But I just want to see those 4 columns. And so I can see, oh, that looks like everything's female. This looks like this did what I expected it to, and so on. So this is not saving any work, it's just printing it out. So I think this is the kind of confusion I've noticed a lot. And I think, oh, raising hands. Yes, Mary, do you have a question?
Hi, yes. I wanted to ask, so in the past, you could just put in the bottom of or towards the bottom of the code chunk, you could just write out like penguins_f. Would that pull it up, or
yes?
Okay.
Exactly. Yes, I actually had, for this purpose, I had opened up the file. Let me find it. Okay. Is it? In the Dropbox today, when I was adding these slides, I added the code from this slide. So let me just run it in interactively too, so you can see. That's the data. Okay, this is that code chunk I'm showing you on the slide. So if I press, I'll highlight so you can see exactly what I'm running. So I'm running this part. We can see that penguins F now is in our environment, along with penguins raw. You can ignore that. That has to do with the package loading the data. Penguins was the original data set. So we have these 2. And we see that penguins F has 1 more variable because I added bill ratio. We see it has fewer observations because I took basically half the data set. And then now let's run this. We can't see anything because I haven't printed it. And so yeah, what you're saying is if I just write this, now it's showing me the output. If I had done that in that slide though, it would have looked more like this, see? And I wouldn't have been able to see bill ratio. So when you're in R Markdown, you get this really nice little interactive table. But if you knit it, and it might look different, just as a heads up. There's a little bit of a difference between like knitting your code and the nice RStudio helper visualization thing. But this one is doing the same thing. It's printing your data, but only showing these columns. So it just looks like, it looks like a table with only 4 columns, which it is, but I haven't changed Penguins F because I haven't saved it as Penguins F. I'm not saving the work, I'm just doing the work. Hopefully that answered the question. Great. So that's what I think of when we're filtering or doing all kinds of work to our data. Save it if you need it later. Save it as something that makes sense to you, like Penguins female or Penguins F or Penguins cleaned or whatever. And then the other side of this is summarizing work. Today we're going to talk about the function summarize, but so far we've talked about table. The nice thing about table that I haven't really mentioned is that while it is summarizing your data, it's also outputting another tibble, another data frame that we can then do some kind of tidying to, which actually was in your homework. You had like the table of tissues or organs. And then the idea was that on top of that, you can then further arrange your tibble. And so we can see that if we have Penguins F table species, we've output this table, but don't save that as Penguins F again, right? Or don't reassign Penguins F as this table. You're creating summary information. You're not creating a new data frame that is like data. What is data? It's metadata, essentially. It's not data that you're going to work with later. Although it can sometimes be useful to save. I might show you a little bit about in terms of like printing and making nice tables. But if we did want to save it, then I would probably say, let's save it as something, some object name that tells me it's a table or a summary or whatever. So this is a new object that I'm creating, Penguins F table species. And so if we glimpse that, we can see that it is indeed a tibble because it's telling us rows 3, columns 3. It's showing me 3 columns, the factor of the species here, N and %. So it's like a new mini table that just has the summary information. And if we ask, what's the class of that? The first class is a table with Y, and the second is a data frame. And so when you have something that has multiple classes, that means you can use them in ways that these are, that they allow you to, essentially. So because data frame is one of the classes, we can use like arrange or filter or all those kind of tidyverse verbs on that result, on this object. And then often packages have their own object classes and type of objects, which have a lot of attributes and functionality and like customized printing and all this stuff. And so that's what you see when you see this isn't class table. You'll see that a lot where the class is like specific to the type of function or package you used. So don't worry too much about that, but just know that this is a little data frame. You've collapsed your information into a summary, and we'll see that again with summarize. So you can save it if you want, not necessary unless you really want to use it later. Let me show you how I know. Where do I keep losing that? One thing I haven't really shown you in, the help documentation, how I know what's coming out of a function is I look down at value. So table, the value of table says it returns a data frame with frequencies and percentages of the tabulated variables. A 3-way tabulation returns a list of data frames. We haven't done a 3-way table yet, and we haven't talked about lists, but we will next week, I think. So it's telling you it returns a data frame. And so we can see if I run this and this, I could say like, oops, I could view that table if I wanted and see it. It acts just like a table. I could look at the dimensions and all of that. Summarize, and we'll talk about today, does the same thing. It gives you another table. So don't overwrite your data with a summary is my main point here, or you'll lose your data. You won't lose it because it's still in your CSV or Excel sheet, but in your Markdown will lose it. And then one thing, like I was just saying, you can use that now that I've saved it, you can arrange it. You could, I haven't introduced some of these nice like HTML table printing things. GT package with the GT function, I'll use that a little bit in class today, is just something you can pipe onto your results and see a nicer looking table. This would look nicer if you had a big table, but you can see the difference between just plain old printing it and using GT. And then in terms of summaries saving, then if you want to save that as a table, as like a CSV file table, you can also do that. So here I had the summary table I've arranged by N, and then I've saved it as a CSV. And I did that all in one long piping statement. The other option is to save that, like arrange it, save it again as that same table, and then write that that object name to this CSV. So we have a question. If you use the adorn functions on a table, do the numbers from the adorns become part of the data frame, or are they extra somehow? It depends what adorn function you use. Things like adorn, percentages, and adorn. Maybe I'll try that. So let's see. So I'm just going to put adorn. Oh, let's do a cross table actually, because here we go. Me trying to do live coding with the table doesn't go well, I don't think, but we will try. Let's say species and sex. Okay, so let me just put glimpse at the end here, and you can see this is a nice 3x4 table. Now, if I want to adorn, let's say totals, now we have another row. That is still going to be a table. You can kind of guess when you start seeing it. I'll just try, let's see if, I don't never remember the ordering, so we'll see if we get a error here. Okay, so let me see if this is a tibble. It is, but you can see something strange happened. Now the column names, because if we look at it, there's this weird extra title up here. When we glimpse it, now the column names have moved down. So depending what you're doing with that result, that might not be what you want. So one way to deal with this in adorn title is placement. You can read this little paragraph, but placement equals combined. So let me just show you this part. Now it's put the names in this one corner. And if we glimpse that, now we're back to having kind of useful column names for further arranging or processing. But the other one I wanted to show is that now we have like species and we have sex, but we have doubles that have the counting. And then, okay, this is where things are going to get hard for me. So percentages. One thing you can do in table is convert, let's not glimpse, convert everything into percentages, and then adorn percent formatting. Someday I do want to go through all the, yes, I want to go through all the nice janitor things, but it matters which order you do things. So this is why I try not to do it in live coding, because I always get confused, but you get to see how I troubleshoot. I rearrange them randomly until they work. So this has now added, before I added this, you could see it put everything in terms of proportions, even though it used the word percentages, but it's basically doing total, it's doing, looks like it's doing row wise percentages, right? Each row adds up to 100 or to 1. But if we want to see that in terms of real percents with percent formatting, this will do that for you. But now you can guess these are no longer numeric. Well, let's glimpse this. Now we can see that we have character vectors. So all of the stuff that table will do for you and make really nice tables, make beautiful tables for you. Somewhere you can adorn ends. This is usually like, I just have example code for myself and just copy it because I can never remember. But this is kind of how I like to do tables, where you have percentages, then you have the n in parentheses. You could think about whether you want it to be row wise equal to 100 or column wise equal to 100, whatever. That's all, those are all options within there. But these are going to be character columns. So it is still a tibble and you can still work with it like a tibble, but now you have to deal with characters. You can't really sort as well by that. Depends what you want to do. So the long answer is almost always yes. Basically yes, but you have to be careful. And yeah, janitor is so useful. When we talk about, I think one of the most common requests for stuff to talk about in like week 10 and 11 was making fancy tables. And one way to get there is with janitor plus various versions of GT, because you can make some really nice data summaries. Yeah, any other, I went on a tangent there, but hopefully that was useful. And you can kind of see like, I like to do a lot of things together. Well, especially with table, you have to, but I do like to put like my filtering and mutate statements all in one long pipe. That is a personal preference. I think I just like to see it all together so it doesn't get lost, but that's one way to do it. The other way is to kind of save each piece, kind of like we're doing here. So here, filter and mutate, and then I arranged. But just keep track of what you're saving in terms of your summaries. The third thing I want to talk about in terms of saving is our functions that are more for you to see your data. So some things you don't usually want to save are output from glimpse. Glimpse just prints a snapshot of your data. That's not really a good, I can't think of a good reason to save that. Things like head or tail, where you're just sort of like interactively checking out your data. You don't need to save that as an object. You can, but why? I don't know. You probably don't need it. Similarly, things like n row or dim or column names or class that pull out one piece of meta information. I wouldn't save that. I would just print it out. You're just kind of adding extra work. If you save it as something and then you have to call its name to print it out. And it's probably going to just be a vector. So I would just use the code and print it out. Do your work, but don't save it. And then skim is a whole other ball game. Skim also, I'll show examples. While it prints a really nice visual summary, you can save it and it will let you do things on top of a skim output. I'll show you a couple examples. The other thing is view. View is a very useful interactive function, but I wouldn't put it in your markdown. Like sure, you can put it in your markdown while you're coding and doing interaction with it, but before you knit it, I would comment out any view statements. So I have examples of all of these. Glimpse, like I said, you could save glimpse as an object. Here I'm saving it as glimpse out. Glimpse actually is unusual in that if you do save it, it still prints for you. It just thinks you need it, so it prints it for you. So you actually save it and then it prints it. And then if you want to call it again, you can say its name and it will print. But I don't really see the point of that. Skim, like I was saying, skim, if you save the output, so here I'm saving the skim penguins output as skim out. If we look in the help of skim, it tells us that the value is a skim df object, which also inherits the classes of the input data, which is sort of a mysterious statement to me. And in many ways, the object behaves like a tibble. So skim out is a complex object. It does a lot of things. And there's a whole vignette about how to use it. I think somewhere in here I have the link. So if I call its name, it prints out it's trying to print out the HTML version of the skim, and it's too big for this slide, so you can't really see what's going on there. But we've seen skim output before, so it's printing out that skim output. And then if I say, what's the class of skim out? It gives me a lot of classes. And so that's what it's saying. It's a skim DF, but it's also a tibble, and then it's also a data frame. And so because it's a data frame, I can glimpse it. And I thought this was interesting. Like, it's condensed the skim output into a tibble. So we can actually use this information later. And that could be actually really useful because it gives you all the numeric value means for your numeric variables. For factors, it gives you a complete missing rates and so on. It even gives you these little numeric histograms and a character vector, which is kind of amazing. So because this is a tibble, I can do tibble-y things to it. I can filter. Here I filtered based on a number missing greater than 0, but we didn't have any column or any, we didn't have any columns that had missing data. So this didn't give me anything, give me an empty tibble. I could also filter based on a type. I only want to look at my numeric values, and I want to look at the mean, and that created a tibble that was 6 rows, 2 columns, has my numeric columns listed with the means there and so on. So you can imagine this being useful. I have to say I don't do this hardly ever, but if you like skim a lot, and oh yeah, here's the vignette, read the vignette, there's a lot of things you can do with that. And then yeah, so the last one was view. Just comment these out. Don't save it. There's nothing to save. If you look at the output of view, there's literally nothing, and I tried to save it and it just told me it was null. So just use that on your own, but don't keep it in your RMD. And then the other thing I want to talk about is saving ggplots again. So here, so I realized that I use save here kind of vaguely, because when I say save a ggplot, sometimes I mean as an object, and sometimes I mean as a file. And so I'll try to be more clear when I'm talking about saving ggplot. Here is an example of saving a ggplot as an object. I've called it p boxplot. Here I've done the ggplot code, and this is making a boxplot. And when I run this code, nothing happens visually. It doesn't print out the plot. It doesn't give me any messages or anything. It's just saving it as that object. And so later I can say, what is the class of that object? It's actually, it has 2 classes, gg and ggplot, both of which are related to a ggplot object. If I want to, oh, this got cut off. But if I wanted to print it, I would say this, and down below there's a plot that you can't see. It's because it got cut off. But if you want to just look at the plot, that's what you do. And you can see that again here. And then the other reason I would save it as a name, as an object, is because I want to use ggsave to save it as a file. Yes, another question, Mary.
I am sorry about the question, but
No, good.
I wanted to ask, when it comes to the requirements for certain publishers of the file type that they prefer, which in your experience have they preferred, like PNG or TIFF?
TIFF is a common one. I feel like there's no rhyme or reason. I don't know. I like Ping because I think it opens in more softwares, and that's my experience. JPEG, I feel like, can sometimes have lower quality, but then also it depends how you save it. I would say that I just submitted to Blood and they required TIFF, which I was surprised at. It depends on the journal, and then it depends on the requirements. Like sometimes they say they want all their figures to be high resolution when you submit it, and you can specify that. I'll try to show an example where you specify the resolution. I haven't really done that here. Here I've shown you can specify height and width, and this will be in inches by default, but you can specify pixels and millimeters or whatever. And the way you change it to a TIFF is I would just write pboxplot.tiff, and it would know that you want to save it as a TIFF. Some journals want, what is it called? Like vectorized graphics, where they can go in and change it themselves. And so I think PDF is one of those, and EPS, but usually they tell you the types that they allow. So yeah, it's easy to change it for what they want, but you just have to make sure to read all of their instructions. Yeah, that's a good question.
Thank you.
Yeah. I don't know if anyone else has had these kind of experiences, but eventually you probably will. I think what I was saying is sometimes they want high resolution and sometimes they want low resolution to submit, and then later you have to submit the high resolution. So writing all the parameters that you want and then being able to adjust them later is actually really useful. And at some point I want to talk more about more advanced Markdown. And because within the Markdown document, the way I often save plots is that if you name your code chunk, like let's say I name it scatter plot penguins, and then there's an option up at the top that you can set to say, I want to save all my figures somewhere automatically from every chunk. And I usually do that. And so I just save everything as a separate file, and I tell it where I want to save it, and I tell it the height and the width by default, and the file type and all that. So I'll show that at some point once we are a little further along in data wrangling. I'll come back to a little bit more advanced Markdown, just because that's really useful. So I actually don't use ggSave that much unless I really want to specify all of these very particular parameters and options. So I was trying to tell you that I saved this as an object because one reason is I want to call it again and save it as a file. The other reason is that now I can use that to add more layers. So if I come back and remember, oh, actually I want to add a theme and some titles. And so I can do that by calling its name and then just adding on all of the extra layers. So here was the original plot, but now I've added the theme minimal just to make it a little cleaner looking. And then I've added this title and changed the x-axis. And then if I wanted to save that plot that I just made, I could just use ggSave as right after that, and it would know to do the last printed plot, but I would probably just resave it as that p box plot and then save it using ggSave, calling that's name. And so now p box plot has been updated to be the one with the layers and the theme minimal and so on. And so the last slide is that all of this has to really do with classes and objects in R. R is an object-oriented programming language like Java and I guess Python and other things. So if you know more about programming, you might know what that means. If not, that's okay. But just know that there are many, many types of objects in R. Usually has to do with like what package and what function you've used. Like if you have done any stats in R, you've probably run a logistic regression, which you run with the LM function. And if I save that output from the logistic regression function as temp fit, and I ask it, what's the class of temp fit? It just tells me it's an LM. And you really have to dig through the documentation to see what that means. And you can look at $LM to see and like look at the value, and it will send you down a rabbit hole of what is the LM object. It usually has to do with printing and then being able to pull out information from the model. And so we'll talk more about that when we talk about statistical models at some point. And so if you want to read more, there's the Advanced R has a good chapter on object-oriented field guide. But my main point is just pay attention to what you're saving. Don't save everything by default. And yeah, that takes practice. Okay, clearest points. I think there were two comments that I wanted to point out because this person liked that all of the just like appreciated that we're around to ask questions. And then this other person said that they enjoyed being able to go back to the video and rewatch it. And so I really appreciated having both those comments because I think that we all are spending a lot of time on this class, and I know that you are all really busy, and it's like, why would you spend 11 weeks just learning about R? But I think this is the only time in your life really that it makes sense to do that because it's hard to do it outside of school. So I appreciate that you all are motivated to learn more are. And I think having this virtual learning is sort of weird, but it gives you a chance to revisit and slow down the class and to look at things that you want to look at again and again. And so I'm going to show the one request about more tricks for displaying data. I'll try to incorporate that and multiple data points. I think we have an example today, and then we'll come back when we do more ggplot examples. There was a request for actual project data processing, and I have been thinking about this. I have a kind of ridiculously messy data set in mind, but I need to go in and like fake it so that it's not real data. And I'm going to try to do that for next week, hopefully, or maybe 2 weeks from now. But today's data is a little bit messier, and it's not too bad, but it has some issues. All right, so what time is it? 4:22. All right, so I warned you that was a lot of pre-class stuff. Are there any questions before we switch to real class 5? All right, I think this is the midterm. Okay, so in the Dropbox, there's part 5. I'm in the folders. I'm working in that Dropbox, so everything I'm doing is being saved in the Dropbox. So you can download it later. This is the code from the slides I just did. This is code that I used to make the data if you really want to look at that. So today, let's see, one thing I haven't really talked about is something I do all the time, which is session restart R. I like to do that because I just ran some code, but it has nothing to do with what I want to do now. So I want to remove all that environment and I want to just start from a clean slate. I do that when I'm knitting, when I'm working from an R markdown a lot, because I know that sometimes I will run code out of order, and I know that can cause my markdown to get riddled with errors if I'm not doing everything in the right order and I specified something out of order. And so I just encourage you to, if you can, restart R and then rerun your chunks in order as kind of a testing, especially if you're getting an error, just clear everything and start all over. So I cleared it. Now I'm running my package loading code. And so today, is that the same? Oh yeah, good question. Is that the same as Broom? Technically, no, because Broom just clears the environment. Broom is the same as rm list equals ls, which erases everything in your environment. But restarting R also gets rid of all the packages. So now I had no packages loaded at all. And I like that better because sometimes I forget to library the package or pload the package first. So that will tell me quickly if I try to run my chunks in order and all of a sudden it says can't find this function name, then I know that I haven't actually loaded the package in my markdown. So you could do either, but I have the habit of doing session restart R. You can also do restart R and clear output, which clears everything from your markdown, or restart R and run all chunks, which actually restarts R and runs all the chunks in your markdown, which is also nice because it's like essentially recreating the knitting within your interactive environment. Okay, so today there's no way, we don't have that much time now, but there's no way we're going to get through all of it, but we're going to work towards it. Today we're going to do a little bit more mutate because I want to introduce separate. I'm going to actually talk about here again because I think it's something that's worth talking about over and over. We're going to talk about summarize, which summarizes our data, and we can talk about group by, which summarizes in categories within categorical values. And then we'll talk about joining data. So there's 2 ways to do that: bind rows and then joins. And then we probably won't get to this, but eventually we'll get to pivoting data, which means turning wide data sets to long. And then there's also ways to turn long data sets to wide. So I've saved this as part 5 mini A just in case I mess up some code. The original will still be there. And again, what I've done with this folder, this part 5 folder, so you have your part 5 R project, which is saying this is my home directory. You can see up at the top here, it's telling me the project name is part 5. It's in this folder on the top right. Also, if I click on this little R logo, if I click on that, it takes me to my project folder, which is here, where part 5 R project is. If I click on this, it tells I can set some settings about the project. And so I've put my code in the code folder, and I've put my data in the data folder, and then images in the image folder. So I've made my code nice and organized. But again, if you were here for the here lesson a couple weeks ago, that can cause problems with Markdown. So the structure of my folder looks kind of like this. I have code. I have a little bit more code in there now, but I have part 5 RMD in my data. I have all these data. And then this is the root. This tells R, this is the root folder. So the function here is used to tell R relative file paths to where this file is. For me, this is where it is in my Dropbox and all these folders, but it doesn't matter. You can think of this as like a self-contained little folder world in this project. R does not look outside that project unless you really tell it to. By default, everything is relative to this folder. So in order to kind of figure out what's happening, I've written just a couple of lines of code here. If I call the function here, which is in the here package, it's telling me this is the root folder. It printed it out for me. And so yours, if you run that, it's going to look different to you. It's going to tell you wherever your project folder is. And so we use here to specify folder names or folder names and a file name. This is the subfolder data. You can see it's just appended data onto where my part 5 folder is. And here it's appended data, data plus the file name. So this is one of the data files. And so when I say I want to read in this data, it's looking in this path. And there's also a function called dr underscore here, which I don't think I talked about last time, but you can run that and it will tell you why it's made that your root folder. This is telling me this is matching a file. This directory contains a file matching .rproj. And so the initial working directory is this. The current working directory, this is important because this is actually where my markdown is inside the code. So what this is saying is whenever I use here, it's not looking in the code folder, it's looking in this folder, just above the code folder, the like container folder. So that gives me a little information. Okay, and then side note about the data, I'm using a different data set today, no more smoking today, or maybe a little bit actually. Actually, there is smoking in this data set too. But this data is a little bit messier because it has some kind of funky columns. I used this with Micah Niederhausen when we taught the tidy wrangling bird workshop. And so this is actually from the Youth Risk Behavior Surveillance System. And so this is survey data, big survey data from multiple years of students and their behaviors and some demographic data. So there's actually an R package that has some of this data that Hadley Wickham made and put on GitHub. And so I've used that. I've taken a subset and then I made it messier and then I broke it up into pieces. And I've also subsampled it. So this is like a warning that because I'm completely ignoring all the survey weights and I subsampled the survey, I've broken a lot of the associations. So if we're plotting things and it looks like, oh, like sex is related to smoking frequency, probably not true. Don't believe it. Don't believe the data. This is like one of the ways to lie with statistics, I guess. Just completely ignore your sampling. So don't do what I'm doing. This is just for educational purposes. But it is a really interesting data set. So if you take the survey class in biostats, this might be a good one to practice with. Okay, so we've talked about reading Excel data. This time I made our data in CSV and TSV files. And that's because I would say it's in terms of reproducibility and kind of open access to data, it's actually more preferred to save data as plain text files. And that's because then you don't need Excel to open them. So if Microsoft ever goes out of business somehow, and Excel just leaves the face of the earth, you'd still be able to open CSV files and TSV files because they are plain text files. There's nothing else in them, just text. CSV means comma separated. So each column is separated by a comma, and tab separated would be TSV. And then you can imagine there's other types of separations. I'd say CSV is probably the most common because it opens in Excel really well. And then all this data is in the data folder. And so we're going to use here to tell R that we want to load that data. So I do want to look at just to show you. So, so this is, here, let's open one of the CSV files. This is from 1993 to 2007. And so you can see it's just a bunch of commas. There's columns, each row is separated out by columns. TSV is not that much different, except now there's tabs here, right, in between instead of commas. So we have 3 data sets we're going to read in related to the demographics, and we have 1 question, which is some of the survey data. I do want to show you what happens when we import the data. So I want to just show you like the interactive way, because I know some of you are a little more used to doing it this way. So I'm going to do import data set from text. Let's do the TSV because I think it's a little more interesting. So here's the TSV data. Okay, so interactive. What is going on here? This doesn't look good. We would imagine that this should separate out into columns, right? So what we need to do down here is tell R that it has a tab delimiter. So by default, it set the delimiter to comma. I don't want that. I want tab. I'm gonna let it do its thing. Now it's recognizing that there are multiple columns. So that's great. And you can see that it's adapted the code. It's set some of these by default. Escape double is equal to false. I think that just means like it has to do with the character at the end of a line. I actually don't even use these. When I write the code, I don't use these options, but when you're doing it interactively, it sets them automatically. And then it changed the delimiter to backspace T, which is the symbol for tab. So as I mentioned when we were loading in data last time, this is one way to do it, though. You do want to make sure you copy this code and paste it into your R Markdown. Otherwise, when you knit your document, it won't know how to read the data in. So I just use the code way, but if you want to use an interactive way, this is one way to do it. The other thing to make sure is that you're picking the right NA values. So you can check your character types. This all looks good. These look like characters. This looks like a double. Record ID could be either, doesn't really matter. So that looks good. And I would use that code if I wanted to save it like that. But I'm just going to show you the straight, no, not this, code to read it, which is, this is how I would read it. I wouldn't even set any options because I would use the function read_TSV, which is similar to read CSV or read delim, but it specifically reads in a tab separated file. So if you noticed in the interactive way of loading in data, it was using this function read_delim, which lets you set the delimiter as a comma or a tab or a space or whatever. Read CSV are really just kind of wrappers or special cases of those that specifically read in comma separated values or tab separated. And so I tend to use those. So here I have an example of both. Read TSV, reading in here data, the name of the file, or read delim, reading in the file name, delim equals tab. I'm just showing you the thing. This does the exact same thing. So then I'm going to save it as RBSS demo 1991. And then in terms of the second and third data sets, they're both CSV files. So I'm going to use read CSV. And you can look at all the other arguments. Again, if you needed to skip any empty space above your header row, you could do that. You could set your NAs to be something else. This data doesn't have any unusual NA values like the one in your homework, I think once had missing, or oh yeah, it was the weird super messy data that I had you read as a challenge, I think, that it had like the word missing was denoted missing data. And I'd say those are the most common arguments that we would use. Skip and NA, similar to the read Excel argument selections. And file, of course, you have to tell it which file you want. But if you're curious about any of these other options, you can read about it. At some point, I do want to show you how to use the call types argument, because that can allow you to set the column types of your columns. I rarely use that, but sometimes it can be useful. So at some point, I'll try and show you an example of that. But here, it's pretty simple. I'd say most CSV files are pretty simple read. You just kind of straight read them in. They usually have a header file, header row, and it reads that automatically. So I'll run this, and you can see the messages is telling me it's read in 1,000 rows, 6 columns, etc. It's telling me like some character vectors, some double vectors, etc. So that's just messages. I can ignore that. So 4:30, let me see how, I want to make sure we have a break. So let's see. Yeah, we'll get to challenge 1 and then maybe have a break. So in terms of combining data sets, so we have these 3 data sets. I've made them separated by year. So this is 1991, this is 93 to 2007, this is 2009 to 2013. And so usually in this situation where we have data from multiple sources that we want to combine into one data frame, and they're all from different populations, like different labs, different clinics, in this case, different years. In this study, each year, they study a sample of students, and then the next year they study a sample of students, but it's not like they're getting the same ID each year, right? Like if I filled out the survey one year and then I filled it out next year, they're not linking those students at all. My ID would be different each year. So we don't need to worry about like matching up IDs yet. Right now, we're really just literally want to stack those data sets on top of each other. So like I said, we have 3 ranges of data. They represent 3 different cohorts from different times, no overlapping student IDs. We don't have to worry about matching data. So what we do want here is the function bind rows, because we want to stack those data on top of each other. And the way I would do that is do 2 at a time. So first, I'm going to stack the 1991 and 93 to 2007. It's all odd years also. So 92, there's no data for that year. So how would we do that? The way that we combine data, I'd say the first step is to look at those individual data sets. Always look at your data when you read them in. There could be things lurking that you don't know about. So here I'm going to run, let me highlight it so you can see what I'm running. Call names. So this first demographic data 1991 has record ID, year, sex, age and grade, race 4, race 7. And I can look at the dimensions of it. It's 1,000 rows, 6 columns. And let's look at the call names of 93 to 2007. Record ID, year, sex, BMI, weight, kilogram. So you can see there's some overlap, but there's a couple columns that are not in the first one. And I'm going to run this whole chunk so you can see it all together. So BMI and weight are in the second data set, but not in the first data set. And so that could be a problem, but it's actually not with bind rows. Before bind rows existed, there was a function called rbind, which is in base R. Rbind would complain about this, and it was, I remember it being an endless struggle. So when bind rows was invented and it just combines them without complaint, it was amazing. So this is a really useful function. So I'm going to bind rows, and my arguments are the two data sets, 91 and then 93 to 2007. And I'm saving that as a new data frame. So look at my environment first. I have the 3 data frames separated out. So let's run this. Now I can see a new data frame was added, this 1991 to 2007. And it has 9,000 rows, which is the sum of 1,000 plus 8,000. And I can see that there are these 2 extra columns, BMI, weight, kilogram. It moved them to the end because if you think about what's happening, the top data set did not have those columns. So then it literally pasted the bottom data set below it, like bound them together, and then found those 2 extra columns and added them to the end. And so they're missing for the first set of data. So it looks like it's all missing, but it's not. They're down below, there's data in those other years. Actually, the earlier years don't have BMI, weight, kilograms. So I think it's starting in like 2003 or something. They started taking that data. So that was actually surprisingly easy. So we can check that we have the right years. I'm taking a table of year, and you can see 91 all the way to 2007. We have 1,000 rows of data from each year. That worked well. And now this next step is going to be a little harder. So again, now I'm going to take that new data set, 91 to 2007, and bind it with 2009 to 2013, which is the 3rd data set down here. That had 3,000 rows. So let's look, I'm going to run this. So these are the column names of that, the result from my binding up above. These are the column names of the next data set. So this will happen a lot if you're getting data from a bunch of different labs and they don't really have a standardized way of labeling their data. Their column names are all weird and not the same. So what do we do here? Let's look at what happens if I just ignore that. I'm going to bind them together with no cleaning or arguments or anything and see what happens. I'm going to glimpse it. That looks not good. So we have all of the data from the first data set here. And then we have some extra columns which were coming from the second data set. And we can see again, because there's spaces and numbers and symbols in here, we get this strange like backtick around the column names. So remember that R doesn't like spaces or symbols in its column names. So that's one problem. And the other problem is we want record ID to actually be underneath record ID. We want age and grade to be under this one, and race 4 cat to be under race 4, and so on. And that's not happening. So we do need to clean our data before we bind it. And there's multiple ways to do that. You could manually rename every column to match. Yes, question.
Hi, just wondering, when it comes to the age and grade, because it's in the same column, can you separate the two?
Yes, you'll see. I did that on purpose. Yes, we'll talk about that. Yeah, normally data wouldn't look like that, but I wanted to do that as an example. Yeah, but after we bind it together, then we'll separate it out. Yeah, any other questions? Okay, so how would we do this? You could rename them all. What I would do here in this case, because we have all these weird spaces, is I would first use that handy janitor function clean names just to clean it. So I'm gonna clean that second data set and look at the call names again. So it's a little better. Record ID now matches the original one, age and grade does. We still have a couple that are not the same. Remember, one of them was race 4. This is race _4 cat. BMI got a little strange because of all the symbols. So I would use the rename function to just rename those 3, race 4, race 7, and BMI to match. So let's run this. I'm renaming them and I'm resaving the data as the same name. And so now let's look at the two sets of column names. And we can see they do match. They're not in order though. They're in a different order, but they do match. This is how I would check if I had like 25 columns and I didn't want to go one through visually and check. This is how I would check that all the column names are the same or a subset of the previous data set. So I'm asking, are the column names of the demographic data from 2009 to 2013, which is this vector, in, remember the in operator from your homework, the column names of the first data set, which are these. And so if I run this whole line, true, 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 true. Sometimes I'll even do table, true, all true. So if I had 100 columns and I check that, I would check they're all true, which means that all of those columns are going to match up to the columns in that data set. So that means that they are all in there, but they are out of order, but that's okay. Bind rows will use the ordering from the first or the top data set, and it knows how to match them up because they're identical. So now I have bind rows, the first data set, which was the joined from, or the bound 91 to 2007, and then the second data set together. So let's bind them. I just want to, like a side note, bind rows you can use like your data sets as arguments and commas. You could also use a pipe because the first argument is a data frame, and that's one way that we know we can use a pipe. So this would have done the same thing. That's kind of a preference thing. And let's glimpse that. So now we have 12,000 rows and 8 columns. They all matched up. We have no weird extra columns. We do still have this weird age and grade thing, which I'll talk about in a minute. And just to check, look at the table of the year. I can see I have 1,000 from each of those years. So that's all good. Okay, so bind rows is, I would say, the more simpler way of joining data together or merging data because you're just stacking it on top of each other. And so we'll talk about actual joining and merging based on key values in a little bit. But before we get there, I want to talk a little bit more about data cleaning because I have that weird, where we go? That column, age and grade. I just want to show an example of one more type of data cleaning, which I think is useful. So let's just look at the data, skim it, just because it's useful. You can see we have some character vectors, we have some numeric vectors, record ID is numeric, and we can glimpse it again and again. They all look pretty normal. Nothing too unusual except for that weird age and grade. So let's look at that table. Okay, so why is it doing this? I purposefully merged these two columns because I want to show you how to separate them. This is a very constructed example, but there are a lot of examples where we would use this function called separate in order to make two columns out of one. So just for like a simple example, I put these two together. So this has age and then it has grade separated by this semicolon. You can even see missing values were put in there as well. So I'll admit I made that on purpose because there's a really useful function called separate that's kind of like mutate, except it does a very specific thing. So we can look at the help function for separate if you want to look at the kind of some examples and just learn about it. The idea is you want to separate a column, a character column, into multiple columns with a regular expression or numeric location. We will talk about regular expressions a little bit today, very, 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 very little bit. That is like a deep dive that hopefully we'll have time to do in later classes. But it is a way of searching strings, basically. Very hard way of doing it, as you'll see. And so here we have age and grade joined together with a semicolon, which is pretty nice because it's going to be easy to separate. There's just one character that we need to separate based on. And the side note about tidy data, this would not be considered tidy data because you have two values in the same cell. If you remember, one of the components benefits of tidy data is that every cell has one piece of information, or this breaks that because it has two pieces of information, and it's just overall really difficult to deal with. The side note is that the opposite of separate is unite. Unite is actually what I use to make this column. Once you learn separate, I think unite is pretty easy to use, so you can look at examples of that on your own. But how do we use separate? The idea is that we start out with the column. So separate, one of the arguments is call, which means which column are you trying to separate? And I want to separate age and grade. And then you have to tell it the name of the new columns that you want to make. I know we're going to need two columns because we need age and we need grade. There might be a situation where you have kind of variable numbers, but you can specify as many as you need. And then you need to tell it the separator. So sep equals semicolon. In this case, I can just see that visually, that they're all separated by semicolons. Sometimes this will take some trial and error to see what your separator is. This one's pretty straightforward though. So I'm just going to run this section of the code real quick. So this is, I guess, a trick. I don't know if I've mentioned this a lot, but the trick I use to kind of test out code and before I really run the whole thing is to highlight the parts I want to run and then press Control Enter to run it. And so when I only do YIBRSS demo and then separate, I can see here, age and grade, 17 years old, 12th grade. That looks great. Not so bad. It looks like it worked, but eventually, I have not actually, okay, here we go. Let's go back. Saw it. Here we go. There is missing data. There was missing data in grade and in age. But if I'm looking at this row, this says NA. And I will admit, when I was writing this code, I at first did not notice this issue. The issue is that it saved NA as a character string NA, not as the special NA value. So R again has a special data type called NA, which is missing. And then you can see it's denoted as like this italicized missing value. Here, but because of the way I separated it, separate makes two character vectors, and it didn't know that it needed to make that missing. So that is why I've added this mutate statement. So on top of that separate, I then I pipe mutate, and I've resaved age and grade using NAIF. And so NAIF is a function in the tidyverse that says, if you see this character string, then replace it with the true NA value. So this is one way to get around, like maybe you read in data and you didn't realize there was a word that said missing with lowercase m, and you only told it that missing with capital M was a true missing value. And so you have to come back and fix it. You can use NAIF to do that. Or if you want to impose missingness for some reason, this is another way to do that. So once I do that and save it, I've saved it as RBSS demo. I've saved my work into the same data frame. We can see RBSS demo, it looks good, it character vectors. I might filter is NA age and glimpse just to see. Actually, maybe just print it. So now I can see there are missing values here, but it looks like it's counting it as a real missing value because it's printing it as this like italicized thing. So that is my way of checking that it worked. Okay, so it's almost 5 and I haven't given you a break. So maybe let's take a 5-minute break, come back at 5, and then we will do a little bit of more strings, and then eventually we'll talk about joining. And feel free to ask questions during break. I know that. Zoom. Okay. One thing I just realized that I didn't say is that you'll notice when we separated age and grade that age and grade went away and it separated into those two columns. And removed age and grade, the original column, we can actually tell it we don't want to do that. If we say remove equals false. So I already saved it, so I'm not going to really, I could rerun it all, but if I had added remove equals false, it would have kept that column in there. So sometimes that is something you want. But in this case, we don't really need that. So we saw a little bit about factors. So far for data cleaning, we've talked about like the dplyr functions, which include mutate. And then there are a lot of other data types and packages that are useful, including forcats, which is for manipulating factors. And then one is called stringr, which is for manipulating character vectors and strings. And it's extremely powerful package with lots of useful functions. It's automatically loaded with the tidyverse package, so you don't have to call like library stringr or anything if you've already loaded the tidyverse. And I really do recommend that you look at the vignette in the cheat sheet here. Some very useful functions, and I'll try to kind of pepper them in. In this case, I'm just showing a couple functions, but there are many, 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 many more. So let's look at grade. We've separated it out, right? We have age and grade, but they're still kind of strange data types. I didn't do this. This was in the data. I did not contrive this. The grade is written as 10th, 11th, 12th, and 9th, and missing. That's nice for printing, but it's not nice for if we want to use those as numbers. I guess we probably wouldn't. We might, if you want to put it in a model as a number, I suppose. But let's say we want to convert it to a number. And so one way we can do that is with the stringr function string remove all, because we want to remove the characters th from the data. And so to do that, we would do that within mutate. I'm taking my demographic data and then mutating, creating a new column name called grade num, just to like keep track that this is the numeric version. And then I'm using string remove all. The first argument is the column that contains the string that we're removing strings from, grade. And then the second argument is the string, the pattern string that we want to remove. So I'm saving that again as our VSS demo. And now let's look at the cross table of grade num and grade. So we can see grade num is 10, 11, 12, 9. And then the original was 10th, 11th, 12th. And so this is a way for me to check that they all mapped to the things that I wanted it to. 9th went to 9, 12th went to 12, etc. And all my missing data went to missing data. But it removed the string, but it's still a character. So grade num is actually not numeric, it's a character. And we want to use that as a numeric variable. We need to make it numeric. And so the way we do that is use the function as.numeric to change a character vector of numbers into a numeric vector of numbers. This only works if your characters are obviously numbers. If you try to convert a letter to a number, it's not going to work. So let's see an example, just like a small little example, 1, 2, 3, NA. As numeric now is 1, 2, 3, NA. If there, oh yeah, good question. If there were other grades like first, second, could you remove those all at once? You'll see an example of me doing something like this. You could. And then I will show you. Oh, first I'll answer this question too. For the package GT, do we need to make sure any other package designs? Oh, that I'm not sure. Let me make sure. So there's a question about package loading. Did I? So if you're having trouble with packages, if you run this, this should install GT, but it might force you to install knitr, but you should have knitr installed already probably to run our markdown. So I wouldn't worry about that, but yeah, maybe you need to install some more packages. Try running this again. But I can troubleshoot you that, shoot that in break or on Slack too. Yeah, sorry about that. Sometimes these packages have unusual requirements that are unexpected to me. But if you can't get GT to work, also don't worry about that. We can comment it out and try again once we figure out the packages. But going back to the question about second, the simple way you could do that is to then first remove TH and then remove ND, or you can use regular expressions to say, I want to remove TH or ND. And I'll show you an example of doing that down below, just so you can see it and make sure I code it correctly, because sometimes I get confused when that is involved. But yes, that is a possibility. And so string remove all is very, very useful. So, okay, good. Glad it worked out. Yeah, so good point on the chat is that when you have GT, I think you do, I guess you do have to load knitter, which I didn't realize that. So maybe I should add that here if anyone else is having this issue. I didn't realize that. I don't wonder why mine worked, but you might need to load knitter in order to get GT to work. And we are going to talk a little bit more about GT in a minute. So it's good to get that working. Okay, so working with text, as I was saying, you can convert a character vector of numbers to numeric with the function as numeric. And so this is a numeric vector, this is a character vector, though you do need to be careful, because if you have some kind of rogue letters or anything else, words or whatever, or even like a one and a, well, actually this I think will work. So let's try this actually. You might get a warning. That's an interesting thing about as numeric, is you're going to get a warning. Oh, this did work. The NAs were introduced by coercion, which is a sign. It's not going to give you an error, but it's a sign that something unexpected happened. So pay attention to that. And this is actually how I noticed that my NAs were not behaving properly. And up above, I had to mutate with the NA if, because I got that warning. And I was thinking, that doesn't make sense. I only have numbers in my data. It should not be giving me that warning. But it was because I had this quotes NA. But you can see it's turned this into NA. It's actually magically turned this into a 1. It knows how to trim the white space and then make it a number. But the A it didn't like, and it gave me an NA. So just be careful when you're using this function, especially in mutate, when you have many, many rows and you can't see all your data. I would run this, mutate, make it as numeric, then run the table of the original one and the new one, just to be sure everything looks good. So now I have, again, 10th, 9th, blah, 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 is converting to 10, 9, 9, 10, 11, 12. Let's look at it. Now, grade num is a double, which is good. The other one is age. This is an odd variable because they grouped all the young kids together and all the older kids together. And then everyone in the middle got their own designation, 13, 14, 15. So it might, you probably actually don't want to convert this to a number, but just for illustration purposes, I'm going to. You're going to lose the information that all those kids are not actually exactly 12. But we'll just try and convert those to 12, these people to 18, and then everyone else to their actual age, just to show you how to use string remove a little bit more complicatedly. And this is a way, like we could have used case when, for instance. I could have said if age equals this, then make it 12. If age equals that, then make it 13. That is one way to do that. It requires a lot of typing, but it is a possibility. Or we could use string remove all. And I noticed that I have a lot of strings to remove. This is similar to the question about removing TH versus ND. I need to remove years old. I also need to remove years old or younger, and I need to remove or older. So looking at what happens if I only remove years old, down here, now I've had 13, but now I have 12 or younger because it removed years old from the middle of that string. And I have 18 or older. So like I showed above in the kind of impromptu example, I could just do that all in a row. First remove years old, then remove or younger, then remove or older in sequence. And that does something nice. It did remove all the things I wanted to remove. And then I can then make it numeric. So here I've made it as numeric. Notice up here again, related to my like slide spiel earlier, I'm not saving this as anything. I'm just doing the work just to show you what I'm doing. And then I'm printing a table. So I wouldn't want to save this as anything because I don't want to save that table. But I'm showing you this is what I need to do in order to get it to be numeric. Remove all those strings, then make it as numeric. But this is one way to do it, but there's actually a more powerful way to use string remove all, which is using regular expressions. And regular expressions is not an R thing, it's a universal programming thing. It's a way essentially to query based on strings in a very, very loose, flexible way. And for short, it's called regex. And if we have time at the end of the quarter, I will try to like actually teach some regular expression syntax. I have never really been taught it. I just have kind of like learned it piecewise. And so my knowledge of it is not that good. I often have to like look it up and make sure I'm using the right syntax. But I do know a few kind of common ways to do things. And one way to remove, for example, all alphabetical letters from A to Z is to put the A to Z inside brackets. So this would be what we would call a regular expression. And it searches strings for a match that fits this query. And so what this is saying is string remove all from age, any letters. And that is a really simple way of removing all the alphabet letters from 12 years or younger, 13 years old, etc. And so I can do that in one line and then make it numeric, and I will have the exact same result as before. Yeah, and NAs as well. I could have also done, this is another way, like I was trying to show, Mary had the question about multiple columns in terms of separate. Separate also takes regular expressions. So you could separate based on any alphabet letter if you wanted. Here I'm removing all the alphabet letters. Here I'm removing any of these words. And so, and I'm not, now that I did that test case, I'm not entirely sure this is the right regular expression. I think when you have brackets, it's like a true regular expression. And then when you don't have brackets, it's more of a, an expression. I don't know how to say it. But anyway, this should remove any of those words. This is obviously a more succinct way to do it. This is a way that works, that is depending on your comfortableness with regular expressions, this would work. So I just wanted to show you this example because there is a deep dive world that you could go into learning about all this. And it's a very powerful way to deal with strings and also to do data manipulation, because if you can imagine, separate uses these kind of regular expressions. So you could separate based on a very specific type of separator that way, in a more flexible way. And that is my example here. So instead of removing the strings, one other way to do that is to separate based on that column and then get rid of the stuff we don't want, essentially. So let's look at age again. So if I separated, for example, on the word years, so I have a column, all of these have years in the middle. I would end up with two columns. One on the left, the first column would be 12, on the right would be old or younger. And then on the left would be 13, on the right would be old. And so let's just look, I'm just going to show you. This is what I'm doing here. I'm separating into two columns, separating based on the word years plus the space, and then I'm removing it and it's false because I want to show you what happens. So this is age num, and this is old, my two columns that I created. I separated on years, so we got 17 and then space old, 16 and then space old, 18 and then space older. So this is like a kind of a trick way of using separate to clean up data. It's not as necessary here because string replace all worked really well, but there are other situations where this might be a little easier. And now that I have those two columns, I have my numbers separated out and I can turn that into a numeric column, and then I can just get rid of old. I don't care about that stuff. All of that information is useless to me. Not always, maybe it is in another scenario, you might keep it, but in this case, I don't need it. So let's just save our work this time. Separate age into age num, which contains the number, old, which contains this old, older stuff. Separate based on years, remove to keep the age column for posterity. Age num, we need to convert that into numeric still because it's still a string. And then I select negative old, which means I remove the old column that I don't want anymore. So doing all of that, and we glimpse it. We now see I have age num, it's numeric. I've kept the age column just in case. And if we look at the table, that looks good. Nice, perfectly correlated 2x2 table. Okay, what time is it now? So another side note about separate is that you can have variable numbers of outputs. Those examples I showed you made exactly 2 columns every time. But what if we had separated age on or? Notice there's only 2 values that contain that. Anything here doesn't have that separator or doesn't have that word. And so what happens if we do that? I just want to show you. I've separated using or, and then I've only selected those columns, and I've taken the first 20 rows just to show you. If it was 17 years old, there's no separator, so it just stays in the first column, whereas this one got separated into 2 columns, 18 years or older. And so I show you this example because this does happen a lot. If you have something that has multiple numbers of pieces of information, you can separate them still. It's just going to leave it as missing if it doesn't have that something on the other side of the separator, basically, or doesn't contain the separator at all. So very flexible function, very useful. All right, so I think we'll have time for one challenge today. I don't think we're going to get to the second one. That's okay. But I do want you to practice a little bit with reading in data again. So this is going to be you reading in the survey data, and then use read CSV because you need to read in the CSV data. You want to clean up the names a little bit and rename the columns so that they have these exact column names, because I'm going to use them later. One of those columns needs to be changed into a character vector, which is not a character vector right now. And then something I noticed in the data is if you make a cross table of cigarettes per day and ever smoked, you might notice some unusual data stuff. So I just want to show you like kind of things you might look out for. So yeah, let's do 10 minutes. Come back early if you're done, or go have a break. So we'll come back at 5:30, and I need to make breakout rooms. How do we do that? How many of those? It's only 10 of you, so we're a small group today. Let me stop recording. All right. Recording. Okay. Looks like everyone is back. Thanks for going through that together. I think that this stuff is somewhat review of what you've already done, but I wanted you to kind of get practice with reading CSV. So here I have my solutions. Okay, so I read it using the read CSV. I didn't need to do anything unusual. And let me just glimpse it over here so you can see what it looks like. The one thing that is probably an issue is that the names have lots of spaces and characters. One thing about Read CSV, I did show you in Read Excel that you can use that name repair and clean the names while you're reading it in. Read CSV, I don't think, at least last time I checked, did not have that option. So you have to do janitor clean names after if you want to use that. So that's what I used here. And then we can look at the call names way down here. Now they have been made into lowercase, camel case, snake case. There's a name for whatever this is, slug case maybe, where you have underscores in between. You can actually set options inside of clean names for it to be different kind of naming conventions. Like instead of underscores, you might use capital letters and glue them all together into one long string. But I like the look of this one. So I think this is a pretty common way to naming convention. So I just use the default, but it's still kind of long. So I asked you to just rename some of them into shorter versions. So I use the rename function. For instance, days smoked equals the old column name was how many days smoked in past 30 days. So I renamed several of those columns. This is actually how I got the list to put in the text. I pasted all the call names together with the parentheses, comma, but that's not important really. And then if I want to look at a table of ever been bullied, you can see that it's true and false. So it isn't actually a logical data. And so I wanted you to make that into a character of yeses and nos. And so I used the if else statement, which I don't think I've actually shown you. You saw in the examples today for the functions of the week, someone used that. So this is like case one, but it's just two options, similar to case one in that we are testing the first statement. So if ever been bullied is true, then yes, otherwise no. And we could have done that with case one, or there's other ways to do that, but this is a simple way. And so if we do that, now we have a table of yeses and nos, same number of trues, same number of yeses. And then the last bit was, what if we look at a table of cigarettes per day and ever smoked? So ever smoked is no or yes, but if we look at yes and the did not smoke cigarettes value, this is somewhat an unexpected, right? If someone said they never smoked, you would expect they did not smoke cigarettes. But if someone said, yes, I did smoke, then did not smoke cigarettes is actually an option for them. But I think what is happening here is because this is actually in the past 30 days. So this is ever smoked ever. This is in the past 30 days. So this is one reason to get the data dictionary and make sure you know what your data is, like what are those columns actually saying. So I think this is a person that has smoked in the past, but in the last 30 days did not smoke cigarettes. So know what your data is, first of all, but then also do some digging to check that your data makes sense. If this had been both in the last 30 days, you might wonder about data input there. Like, why are those people picking yes if they did not smoke cigarettes? So that's something to be a little worried about. So this is just me doing, because I needed it for the knitting. This is all that stuff all at once in the challenge. Were there any questions about the challenge? Might not have finished it, so we'll see how this goes. So actually, just to show you, I actually did everything in one pipe, which is a possibility. I read it in, then I cleaned the names, then I renamed, and then I mutated. So I didn't save any of the intermediate steps. I just ran all of that code together. That is something you can do if you like that way of doing things. And so just another example for case when, kind of like in your homework, which is not due till Friday as a reminder. So all these hints are probably going to be helpful if you haven't done your homework yet. If I want to make a column called cigarettes 10, which converts it into 3 categories. Here we go. 3 categories: none, 0 to 10, and greater than 10. That is a situation where I would use case when. So I would say, create a new column within mutate. The new column's name is cigarettes 10. And I'm going to say equals case when cigarettes per day double equals did not smoke. That's none. Cigarettes per day is in one of these two, 11 to 20, and then more than 20, which is greater than 10. And then true, which is everything else, is 0 to 10. And then I'm going to create a factor out of that, and I'm going to make sure those levels are in order, because those aren't going to be in order if I didn't do this. And then I'm not saving this work. I'm just, because I want to show you something. I'm making a table and I'm adding the title. So let's run this. So one thing to note, let's just, it's sort of confusing that I printed both tables. So I'm just going to run this part. So this is the 2x2 table, right? Cigarettes per day. I made a 3 category cigarettes 10. One thing to notice is there was missing data in cigarettes per day, but it's mapped them all to 0 to 10. So I've shown you this trick of putting true at the end and mapping everything else to that value, but I need to be careful because there was missing data. So another reason to always make a table when you create, always look at the thing you created, always make a table of the categories you've created, because there could be surprises. So what happened to our missing data? We completely ignored it and just saved it as the middle column, the default column for everything else. And I was doing that because I wanted to save typing. I didn't want to write 2 to 5, 6 to 10, less than 1, and 1. I just lumped them all together, kind of like fact lump, sort of. But what we needed instead of that was another line that says, if cigarettes per day is NA, so this again, it creates a true or false value, then make it NA. The weird thing about case when is it expects your value on the right to be the same type. It always needs to be a character. And so R has special, not just NA, but NA underscore character and NA underscore, is it in real? NA underscore real is the numeric version. NA underscore character is the character version of NA. If I had just put NA there, it would have complained and said, no, that's not a character. You're not doing the right thing. So you do need to just make sure you're putting NA character here. So this is all the same code. I've just added this line. This time I'm saving it, but let's look at the cross table now. So now NA is in the right place. NA has gone and created a column of NAs, and everything looks good. So this is another example of things that could go wrong. And then for factors, so you saw a couple examples of for cats functions. So we were just talking about stringr, that's for strings, for cats is for factors. I also encourage you to look at that vignette and cheat sheet. They're very useful. Actually, so for some reason I was thinking that the other one was fact other, but we saw fact collapse and fact lump and all the versions of lump. Here I'm going to use fact collapse and then fact other, which is another for cats function. So instead of case when, I could have made cigarettes per day into a factor and then used these for cats functions to do the exact same thing, but make this a factor, essentially, but make it a factor with 3 levels. So we saw the examples today of like collapsing a longer set of categories into a shorter set of categories, and that's exactly what we're doing here. We're doing the same thing. So the way that we would do that is what I would do in this case, just to avoid some extra typing, is to say, first, I want to make cigarettes per day a factor. So I say factor cigarettes per day. And then I'm going to use the function FCT fact other. What that does is it keeps some categories and then lumps everything together. So it's sort of like fact lump, except fact lump uses, like we were seeing, kind of properties of the factor, whether it's common or rare or it's so on, above a certain number, etc. Fact other explicitly lumps everything else into a category that you don't name. So in this case, cigarettes 10 fact, I keep the ones that I want to use later, and I collapse everything else into 0 to 10. And in this case, I don't have to worry about NAs because the NA is preserved in the factor, and with all of these factoring functions, NA is still preserved as an NA. It's not turned into a factor or anything. So that's one nice thing about this. Though I will say, because of the way I'm doing this using fact other, and then I'm going to use fact collapse, it's a little more, takes more steps and a little more finagling and probably a little muddier, I would think. But it is a way to do it. So just to show you, like I said, I'm collapsing everything except these three. So these three levels I put in the keep argument, and then there's an argument other level, which I've specified as 0 to 10. So let's do that. And I'll show you what happened. Not done yet. I've created this new factor, cigarettes per day, and I only have collapsed some of them. So I have 11 to 20, I have did not smoke, I have more than 20, and then I have everything else in 0 to 10. So these stayed in their respective groupings, but then everything else went to 0 to 10. And so I need to do one more step because I need to combine 11 to 20 and more than 20. Those are my other collapsing categories. So for that, I'm going to use fact collapse. And so I've further mutated this data set, and I'm saying make cigarettes 10 fact, now collapse that using FCT collapse. And I'm going to say none, I'm going to leave as did not smoke cigarettes, and then collapse greater than or equal to 10 into these two collapse those two categories into greater than or equal to 10. So we saw examples of fact collapses at the beginning of class using it like this. So when I run that now, I can see I have done exactly what I wanted. Though I haven't changed the order yet. I forgot to do that. So the order of my levels is not what I wanted it to be, right? I wanted it to be none, 0 to 10, greater than 10. So I could use relevel, I could use fact relevel from the forecast to do that. But I got the same, essentially the same groupings that I had from case one. I, of course, wouldn't really argue to do this because it's just still a lot of typing. You could have done it all with factor collapse. I could have made the third category 0 to 10 and then explicitly written out all of these categories. That is one way to do it. You just have to type them all out or copy and paste them all out. So just this whole part of class really is to show you there's a lot of different ways to do things. Some require more typing and thinking than others, but it depends which way you're more comfortable with. So that's kind of nice. Right, so in the last half hour-ish, I want to start with joining tables because it is a useful thing and it will be nice to kind of see it twice. So the next sections, I have joining tables, which is kind of like the extension of bind rows. At some point, we talk about summarize. We probably won't actually get to that. And then reshaping data, definitely we'll talk about next time. So in terms of joining tables, I mentioned for bind rows that we just were stacking them on top of each other. If we want to actually join two tables that have overlapping, let's say patients or subjects, but different information, that is what we call joining data sets. So let's look at this kind of miniaturized example. So let's say we have two data sets, call one X, call one Y. We have like a record ID column or something. Usually the nomenclature for this is a key. So this is our key column. We have subject 1, subject 2, subject 3, and subject 4. X contains some X variables, Y contains some Y variables, different data, possibly overlapping data, but usually different data. And then we want to put those together in one data frame. And so the idea is that the 1s would match up, the 2s would match up, and the 3 would have a row and the 4 would have the row if we want to keep all the data. This X and Y, usually we call this the left table and the right table when we're thinking about joining two data sets. So in this case, this is X is left, right is the Y. The key, like I said, is this column and colors that we're using to map those two tables together. And there's a common variable between them. They should be like the same kind of type. Like if it's a character vector, it should be character vector in both tables. Something to keep in mind. And so if we match people or mice or whatever your data is on with rows with identical keys, we can make one table that incorporates information from both tables. And there are many kinds of joins. We'll talk about a couple: inner join, left join, right join, full join, anti-join, there's even semi-join. I would say the most common usages require either an inner join, a left join, or a full join. And we'll talk about when you would use those a little bit. Just to get started, we'll talk about inner join first. So what that means, you can see this is going to be a little animation. We're only taking the rows that have matches in both the left data set and the right data set. So inner join removes those 3 and 4 subjects and only keeps subjects 1 and 2. And it's made one table matching on those values, and then X data and Y data is put together in the same table. So that's really the idea of joining. And it's what kind of join tells you what data you're keeping, basically. And so, like I said, we're matching rows based on our key being the 1s and the 2s. If there's not a match in both tables, then we don't keep that key, we don't keep that row. And so in R, and I guess I should mention, all these joins are named like this because in SQL, which is a database, essentially programming language and system, that's what they're called in SQL. So it matches the kind of database language. And it's just kind of a common term for joining data. But in R, in the tidyverse, there's a function called inner_join, where you specify your X table, your left table, and your right table, and you specify the key. Sometimes your key is going to be named differently in the two tables. So you're allowed to say, let's say record equals record ID or something like that. So in the left column, maybe you have a record column, and on the right data, you have the record ID column. So this is a kind of simplistic syntax, usually the typical way we use it. Usually there's just one column that we need to match on, but sometimes you might have 2 columns or more that you're matching on, and you are allowed to specify that. I think next week we'll do a challenge where you have to do that. And so inner join, the first 2 arguments are the 2 tables you're joining. Because again, the first argument is a data frame, you are allowed to do this like the tidyverse piping way, dplyr way or whatever, where you put the first table, your left table, and then you inner join based on your right table. I tend to write it this way, I guess. I don't know why. I think it just makes more sense to me, but this is another option. It's the exact same code. It's just now you're using the pipe. Okay, so inner join. Inner join you're going to use when you want to only keep matching keys. Full join is kind of like I don't want to say opposite. It's not the opposite. It's the big join. I don't know. It keeps everything. So you can see here, 1 and 2 matched up, so they got the same row. 3 did not have any data in the right column for right data, so it got a missing there. 4 doesn't have any data on the left side, so it got moved down to another row, but has missing data there. And so full join is, I would say, is actually probably the default one to use if you're not comfortable with all the other joins, because you don't lose anything. And so you can always start with the full join and then filter based on what you really need. So maybe you'll filter based on that value not being missing or the Y value not being missing and so on. So kind of think of this as a default, but the syntax is the same. You would do the same thing, but just replace it with full join. It would be the exact same code, except you use literally full join here. And so I'm moving on to left join because I would say left join is the one I use the most often. So let's look at that. Left join keeps only data that is in the left data set. And so why would that be useful? I use this most often because I think of the left data set as defining my cohort, is defining my study population. And so in this example and in this challenge, we probably don't have time to do, but next week you'll do a challenge where you join the demographic data with the questionnaire survey data. And in our example, the questionnaire survey data is actually a subsample of the demographic data. So you are keeping everything by doing a left join, but let's say the demographic data defined a certain cohort that you're allowed to study, and your right table has maybe some extra people that aren't in your study population and you don't care about their data. So I would do a left join to kind of merge onto the left table all the information that's in the right table that I care about. And so it's called left join, obviously, because the left table like drives the information. We keep all the rows in the left table, regardless of whether there is a match in the right table. And then, so that's what's happening here. 4 goes away, but 3 is staying. and there's no information in the right table. You'll get NAs because it's missing. And let's do an example with left join. So these are a couple little toy data sets that are in your data folder. So let's read them in. They're Excel data. Here, let me actually just open it. There it is. Can I open in Excel? Yeah. So you have this data set. There are 2 sheets. So the first sheet has 4 patients. The second sheet has 4 patients. We can see just kind of by glancing at it that there's some people that don't match up, the bottom person. And just this has the demographic information. This has some lab values. So I want to do a left join where I only keep people in this cohort because this is my study cohort. I only care about these people. The lab sent me all their information that just because that's what they did. They sent me all the values they had, but I don't care about this last person. They're not in my study. So I'm going to do a left join that's going to actually remove that person and map these keys and then pull in WC value and add it on here and give me that, match up those people's data. So let's look and notice I did read Excel. I said sheet equals 1, which is the first tab, patient table. And then the second tab is the lab table. So let's read that. WBC stands for white blood cell count, by the way. And so patient table, you can see that read in nicely. Actually, we can see that the date was read in as this kind of funny date type, which we'll talk about at some point. Haven't gotten to dates yet. There's a lot of things to cover. We'll get there. And then patient ID, WC value. Okay, so if we did an inner join, oh, I guess I thought my example was a left join. Let's do an inner join and a left join. So inner join is only the data that is in both tables, right? So the first table had that 4th person that wasn't in the lab data. And so we only got those 3. Oh, I think actually it was a challenge for you. But let's say switch this to a left join. All you have to do is change that to say left join. And now we can see we have the original 4 people. Maylin was missing a white blood cell count, so now she got a missing value here. They had the same record name, so this actually wasn't that. This actually isn't needed. if R can auto detect what column name matches and they're the same, you don't need to specify it. It actually tells you joining by patient ID. So always read that little message that it gives you, because it might give you something you don't want. So in that case, you would need to specify what you want to join by. So that takes a little trial and error sometimes if it's not joining by the right stuff. But yeah, that's not that hard. If it's a simple kind of join, you shouldn't get any weird things and weird errors. It just added that column and brought in the data that you wanted and matched everybody up. Very powerful thing. What time is it? So when do we use which join? There's a couple links I put in here that will give some good explanations. I tried to give a little bit of information. So for inner join, obviously you only want data that is in both tables, like the overlap. Left join is when you only want data that is in one table. Often the right table is going to be a subset of the left table, so it's easy to just use a left join and keep everything in the bigger table. But oftentimes the left table contains a cohort of interest or your study cohort. And so, like I said, I would use left join to only take in the lab values or whatever other values are defined by the left table. So you might ask why left join and not right join. I never use right join. Right join is the same thing as left join, but backwards. So that again is a personal preference. I don't know if it's just because like I read left to right that I think in that way, where the left side comes first and then I join. Some people might think that the right side comes first and then you join. So that is a full personal preference. They do the exact same thing. They can do the exact same thing. But personally, I never use that. Full join, I use when I want to keep all of the data. And it is a good idea to maybe just do that by default and then filter based on your data later to kind of come up with the cohort that you need. Anti-join and semi-join are, I rarely use those. Those are kind of very specific situations. They join as kind of like exclusion criteria. So anti-join finds, now I'm getting them confused actually. I think anti-join maps everything that is like all the keys that are not in the right table. And then semi-join maybe is the opposite of that. I get them mixed up. It's essentially a way to kind of come up with exclusion criteria or find any unmatched keys. So if you have giant tables and you're not sure if you have any unmatched keys, like if something is in the left table but not in the right table, you could use anti-join to pull out all the stuff that doesn't match and then look at that and see what's going on. So that is a powerful thing if you're really dealing with big data, which I don't deal with all that often these days. And so read more. These vignettes have some good examples of when you would do that. The warning I have that I don't have time to go over this week, maybe eventually I will show you an example, is what happens if you have duplicated keys. So if you have like 2 rows of observations from one subject and you are only matching on key, you're going to end up with weird duplicated rows. And I'll show you an example because it can get very complicated. Usually in that scenario, you shouldn't just be matching on key, you should be matching on key and something else, probably like date or time or something that's denoting why you have multiple rows for that subject. So that can just make a huge mess if you're just matching on duplicated data rows. So just keep that in mind when you're joining. The more complicated examples we have, the more opportunity you'll see to deal with that. Oh, and this was where you were supposed to change this to be left join when I did that for you. And so I don't want to do a challenge that lasts like 10 minutes. So I might come back and just start this on next week. So I do want to introduce summarize just quickly because it might be useful for your midterm. those of you who know R probably have already used summarize, so I don't want to put anyone at a disadvantage. And so switching gears totally from joining down to summarizing. We'll start next week with some joining again, and then we'll do challenge 2. In terms of summarizing, totally switching gears. So summarizing has nothing to do with joining tables. I wanted to show you this because similar to, we've been using table a lot. Summarize is a way to summarize your data. So surprise, it makes summaries of your data and it outputs a table with this information. So if you think about it, you have data and you want to collapse it down into like a summary statement about your data, whether that is an average or a count or a standard deviation or something. That's what you're outputting. And so, for example, super easy way to just look at averages or means of numeric variables. I use the summarize function after piping. So I take my data, this is just my demographic data, and then I summarize and I say, I want to make a column called average age, which is the mean of age numeric, and I need to remove some missing data. So let's run that. And so what this made was a little tibble, a mini tibble, 1 by 1. It calculated the mean age at 16.1. So that, if you need to calculate some summary statistics, really simple way to do it. There are many functions that will become useful to you, like mean, median, standard deviation, SD, min, max. You might, if you care about like ordering, first, last, nth, there's percentiles, there's n distinct. And so by itself, summarize is nice. You could actually do multiple summaries in one. So let's say SD age, but not me, SD age num NARM equals true. If I run that, then I can get a column of standard deviation. And then I could even have done that with average. That's another numeric one, I guess, year. I don't know why you would calculate this. The average year of the data was 2002. So you can do this with multiple numeric values. There's also things you might want to pull out for character values. I'll show you that if we have time. But just a side note that summarize is very useful. But when it becomes super powerful is to pair with a function called group by. And group by is sort of like a helper function. It doesn't really do much by itself in terms of the output, but what it does is it tells R, we have these groupings, we have categories in our data. And so split our data by those categories inherently. Nothing major is done to the data in terms of like what it looks like. And then we use summarize to do some sort of summary calculation. So we can see in this little figure, let's say we have some grouping and there's 3 categories. One of our columns defines these categories, and then we collapse into summary statements or numbers, but within those 3 categories. So let's say we wanted to calculate the average age or the mean age between males and females. We would first group by sex and then summarize average age the same way we did above. You still hear me? I feel like my headphones are dying and they're yelling at me. So let me know when I time out, I think that's a sign I should stop. So in terms of group by, all it did was tell R that I wanted those summaries by female, male, and also did it missing for me. So notice that NA is a category of sex here. So when we group by something, we can look and see what happens. We can glimpse it. It gives us this little note that it is grouping, but it doesn't change the data. It looks the same. So just be aware of that. It is doing something kind of behind the scenes. And so just another example, like I showed you, we could calculate mean and standard deviation. So if we did that by sex, we'd have mean age, SD age, female, male. And we can group by multiple variables. So if we wanted all the combinations of sex and grade, we can do that. So we have female 9th grade, female 10th grade, male 9th grade, male 10th grade, and it's done all those summary statements together. Just want to show a couple, this one last example, because with factors, and groupings. You might just want to count, like a quick way to count up number of levels in your group. Obviously table is the exact same thing. So by itself count isn't that useful, but you could kind of pair it. Like what I would do probably is do this, add count equals n, and add it into my column. So now I can see there was 1,600 females in 9th grade. That was the mean age, that was the standard deviation age, etc. 29 missing. So table will give you this information, but using count within summarize can be useful if you're putting it all together. So that's nice. So I think I'll just mention that right now that you can use summarize with a cross, like we used mutate with a cross, but I'm not going to start that because we have like 2 minutes left. And we'll talk about that next week. So we have a lot to do next week. Your midterm is officially assigned, but it's not due for a week and a half, basically. Any last questions before we sign out? It was a whirlwind. All right. Well, have a good week, and I will see you all next week.
Thank you.
Thanks.
Thank you.